It looks like we've begun the webinar here. So if all the attendees could go ahead and hold on for just a couple of minutes, we'll be starting here sharply at 1 o'clock p.m. Central Time, 2 o'clock p.m. Eastern Time. Thank you.
SimTech 2025 webinar hosted by the Woodworking Network. My name is Ryan Wagner. I'm the publisher of FDMC Magazine. This webinar will be presented by Kenny Belfato, the National Sales Manager at SimTech, and he will be joined by Giovanni Ramos, Sales Associate at SimTech, to help provide you all with some great information during the course of this session. If you should have any questions during the session, please use the questions box at the top right of your screen in the GoToWebinar control panel. Otherwise, hold all questions until the end of the session. We will also be publishing small survey questions throughout the presentation and recommend all attendees to participate so we can get some great feedback and continue to improve. Thank you very much and enjoy your educational experience. At this time, please welcome Kenny Belfato and Giovanni Ramos.
Hello, everybody. Thanks for attending.
Happy Tuesday,
Today
everybody.
we're going to talk. Hey, there's Giovanni. Hi, Giovanni.
How you doing?
All right. Today we're going to talk about the automated manufacturing solutions for 3D models and assemblies. As we move forward in time, more and more people are moving to 3D models. And you always had 2D drawings. Well, this is the next progression. We'll start drawing in 3D models and assemblies. Let's see how we can manufacture those and make manufacturing easier for those. SimTech is the company that makes the software. Our name, Sim-Tech, is also our website. We've got the dash in there. And it's a software company that's been founded since 1986. Even back then, we realized your machine is only as good as your ability to program it. You're going to
Hey,
spend a
Ken.
lot of money. Yes, sir.
Hey, sorry, bud. Looks like we cannot see your screen at the moment.
Oh, all right. Sorry about that. Let me find out what it takes to see that. All right. Sorry about that, folks. I had to pick an extra button on there. Thank you for alerting me to that. Here's the our website, sim-tech.com. And again, we realized that your machine is only as good as your ability to program it. And back then, we became one of the first integrators within AutoCAD. And so we have both CAD and CAM integrated in the same place. These all the features were generated in RouterSim specifically for CNC routers. It wasn't a different type of package that's converted for woodworking. This was from its inception specifically for CNC routers. Today's discussion, we're going to talk about the benefits of modeling in 3D. Again, like I said, you always had 2D. Well, with the 3D, you'll be able to do a lot more visualization and more information about the design gets captured with the 3D model. Then there's going to be some bottlenecks. You know, it's nice to be able to model it in 3D, see the whole thing, get the weight and all the mass properties and so forth. But there could be bottlenecks, and we're going to show you how we can eliminate those or get past those. Using this program called SolidSim, it's going to bridge that gap and let you take the 3D model all the way through to manufacturing with the least number of clicks, the least number of steps on your part, and give you the best results in just a few steps. after this presentation, we'll have some time for questions and answers as well. I'm also available to do a personal demonstration for you at any time. There's a survey question for you.
Thanks, Kenny. And before we get into that, let's look at our first survey question for everyone. Are you currently modeling or designing in 3D? Yes, no, or would like to? We'll give everyone just a moment to submit those answers. All right. Thanks everyone for participating in that. Looks like we have a pretty good mix here. And Kenny, let's go ahead and get into some of those benefits of 3D modeling.
All right, so we've got some pretty neat pictures on the screen here, and some of the benefits. Well, first off, you can use real materials. You get photorealistic rendering, and that allows you to visualize the product completely assembled. And those material names you use in your modeling program carry across to the manufacturing as well. When you're modeling, you're putting in the depth for counterbores and dados and rabbets and pockets. That depth carries through to manufacturing as well. You know, when you're in 2D, there really isn't a depth, so we don't know how deep to drill the hole other than a note. You get other things too from 3D models like mass properties. You can figure out the weight of the product, the center of gravity. There's a lot more information in the model when it's in 3D. You also get bill of materials. So you'll know for example, the total number of uh, square feet of a specific material. So you'll tell it, 3 shelves, 4 doors. All the information is in a bill of materials on there. And you get to visualize the fit and finish. So if there is anything that doesn't close properly or when you assemble it, the program can show you interferences and it can tell you how much of an interference there is between doors, for example. Just some of the benefits for modeling in 3D. Now, there could be some bottlenecks too. And traditionally, what people do from a 3D model is they'll make a drawing view. They'll look at it from the top view and make a drawing view, and that gives you an outside edge. It gives you the cutouts, and it gives you the counterbores and the countersinks and holes and things like that. But you don't know the material it's on. You don't know the depth of cut for any of these interior objects, right? And you don't know the thickness from the outside geometry. So to overcome those bottlenecks, we have the solution with SolidSim is going to automatically pick up the depth of cut, the material, all the information from the model gets transported. You can also put in things like label fields in your models as well. You can add those what's called part properties. You can add in like due dates and customer name and work order number and things like that. So these bottlenecks, we're going to eliminate those using the SolidSim, where we're going to pick up the name of the part from the solid model, the material from the solid model, all the depths of cut from the solid model, and not on this list, any of the extra properties for label fields. And you'll get another cut list here. It also sizes up the panel so that you can use that for a panel saw if you like. All that information from the parts also gets transported through to labels, and you can customize the labels with the router sim because a lot of parts are going to look similar. So you're going to want to make labels so you can find out which part is which. Some of them might only be just a fraction of an inch off in dimension. So labels become very important, especially if it has the panel sizes on there. You can put whatever bits of information you want onto the labels. We've also got an advanced labeling feature called Touch and Print that lets you touch on a part and print a label. Now, one of the benefits of using modeling packages like SolidWorks or Inventor or Solid Edge or Creo, any of those, they offer what's called configurations, or it's known as many different names, but configurations let you model a product and double click on a size, for example, and this is the same model with 4 shelves, then 2, then 1. All right, and all they have to do is just double click it in the tree and it'll resize or redo the models. If you've got family of parts like this, boy, one model can show all the different family of parts in what's called parametric configurations. You make the configuration you want on the screen, you pick a button called Solid Sim to go ahead and cut and nest those parts. Big feature, which there is no comparison to anything in 2D like that. All right, so you can do these configurations. There's another survey question.
All right, thanks, Kenny, for breaking down those challenges versus the benefits here. And we do have our next survey question for everyone. Do you experience any of these bottlenecks while working with 3D assemblies? And please select all that apply to you. Redrawing in 2D, lack of drill or dado depths, lack of material information, assigning label information, or other, or not covered here. And we'll give everyone just a moment to put those answers in. All right, amazing, everyone. Thanks for submitting those answers. It does look like redrawing in 2D seems to be the biggest challenge. So Kenny, let's go ahead and get into the next segment here where we can see what the solution may be for that.
Thank you. Here's where Solid Sim bridges the gap from a 3D assembly all the way through to nested toolpaths. Traditionally, again, you do one part at a time from a 3D model. We can digest an entire assembly. So we can take the whole assembly, lay all the parts out flat, and then cut and nest them. That's what this Solid Sim does. It saves you an enormous amount of time from working from either single parts or from a whole assembly. Now you'll see you'll have full control over the direction that the parts are laid. If you see this little flat screen here, the parts are all long in X. That's the default. If you don't do anything, they're long in the X direction, but you have full control over that. We can gather the direction from the grain on the material in your modeling program, or you can emboss a symbol to rotate the part at any specific angle. Of course, you're going to have full control over the grain. Also, which side faces up. If there's counterbores on one side and dados on the other, the side that had the most volume and material removed will face up. So the dado side would face up by default, but again, you can change that. And then here your nest results can have parts inside of parts and multiple stock size, stay down, common line, different types of solutions. So let's take a look at a demonstration, and I'll guide us through it. Here's our web page is sim-tech, because there are a lot of different sim techs out there. We've got the dash in the name. And again, this was established in 1986 with the same group of guys making the software. And we've got a whole suite of products. The Solid Sim is the one that was uniquely designed for the 3D modeling. It does what's called automatic feature recognition. Now here's an assembly from inside of SolidWorks. And the parts have a material in SolidWorks and they have a name in SolidWorks. And you've got some settings so you can ignore things. You know, if it's smaller than a 4-inch cube or thicker than 2.5 inches, you can put in these minimum and maximum settings. It'll make drawings or DXFs and you choose the layer names. It'll put things on different layers for you. So any kind of holes will be on layer hole. You can also exclude or include different properties of the objects in the assembly. So take only materials that begin with MDF. You know, if you had glass and stainless steel and things like that, you could exclude those. Or you could just say, give me the MDF material. That's a new feature in SolidSim 2025 that makes it so you don't have to suppress anything. Now it's just one click in the SolidWorks or in Inventor or in AutoCAD. It's just one button pick that does the automatic feature recognition. And what this does, it converts the model into those intelligent drawings with geometry on different layers. And this just takes a couple seconds, and it's going to give us a cut list that has the name of the part, the material, and the quantity. It's going to have all that information built into the cut list, and then we could just cut right from the cut list. So this is the feature recognition process. It's inside AutoCAD now. And here's a CSV file. It's like an Excel spreadsheet. That's the cut list. It creates that, and there you'll have the names from SolidWorks are in there, and then their materials are stored in the CSV file or the cut list. So there you see name of part, material, and quantity. So name, material, and quantity are in there. Then there's the different panel dimensions and the different X, Y, and Z panel dimensions as well. And if you had any label fields, they'd be in these other columns as well. Now, right from that CSV, you can cut it, and then it begins processing the toolpaths and making all the single part programs, the labels, and the nests and everything else. But before I do that, there's a neat command here called expand, which is useful to see like an exploded view of the model. You can either type in a distance or you can drag with the mouse to do the exploded view. This is useful because you can make a copy and paste this into a Word document or put it in a PDF file. It's at this point, it's just a picture, and then you can see in AutoCAD what the features are. It made something on layer pocket cut, and it picked up the depth that was specified when they modeled it. We have a rounding feature as well. If you've got pockets that are 0.24 and 0.26, they can all be rounded out to 0.25 in the layer name if you like. There's some holes, or drill holes. They're on a layer called hole with the diameter and the depth. That's the step that saves the most amount of time, especially if you're used to working from 2D drawings, making a drawing view of the model. It picked up all those depths. It picked up the material name. And in the next example, they'll also have the like label field information. So here they're going to cut that CSV file, optionally save the model, or just exit out of the SolidWorks altogether. And now the RouterSim program is going to go and act on that CSV file. Now, this is showing you our SolidSim and RouterSim program right out of the box, but we also offer something called AutoSim, where you can just drag and drop Excel spreadsheets or 3D models into a folder, and they're acted upon automatically. So we do have quite a bit of automation included right out of the box, but if you want even more, we can have completely hands-off manufacturing, and we could talk about a program called AutoSim with you if you're interested in seeing that. It's completely hands-off. You just drag and drop models or spreadsheets. There you can import from CSVs and from Excel files. They're importing this CSV file. It knows what each column is. It knew that the name was the first column, then the material, then the quantity. But you can map out your own spreadsheets and tell it that the first column is quantity, for example. There's your material properties and whether things can rotate, make scrap cuts, save scrap, use scrap, skeleton cutting. You can also put in alternate sizes. So if you have materials in 4x8, 5x10, 5x12, we can nest by yield or by price or priority. So you can tell you have 5 sheets of 4x4 and then 6 sheets of 5x10 and 8 sheets of 5x12. You can put in these different material sizes and their costs, and then you can nest by priority or yield or price. So they did add 5x10, 5x12, put in different costs, and I'll check the box for best yield or best price. And it goes through the list and tries nesting in all the different sizes and gives you the best yield or the best price. If you don't like having a lot of scraps, then best yield will fill up the sheets for you pretty good. They're also going to do a part multiplier, 10 of these. So you could say Why just make one? Let's make 10, 20, 30. You can also mix multiple jobs together. So give me 10 of these with 5 of these and 6 of something else. And all of the MDF from those jobs will nest together. All the plywood from those jobs will nest together. So there's advanced nesting features in there. At this point, it went through and processed the parts and lays them out in the nest. And there it looks like one of the larger sheets and 2 of the smaller sheets. And each one of those gets printed to a PDF file or to a regular printer or both. You can do electronic print or hard copy print. And when you open those results, you've got all the data there for your single part programs, your nested programs, your labels, your reporting, simulation files. It's all saved, and that can go to your local drive or to a network drive. There's your NC code. And of course, we make post processors for just about any machine out there. And the PDF file has, this would be what would print out to a printer. How many of each sheet? Looks like I used 2 4x8s and 1 5x12. And it prints those out as well. So you can see where to put the labels on there. It's got the part numbers on it. That's the part number of the row from the spreadsheet. Here's your labeling. So RouterSim includes the full labeling, and you can customize these with whatever data you like. You can put 2D barcodes or 3D barcodes on there. And then there's also the touch and print program that I discussed. This lets you see what the nested sheet looks like, and you pick a part and print a label. Pick it and print a label. I had it set to print to PDF files, but you can print those to the Dell or the HP LaserJet, and they'll print whatever printer you want. And it shows the whole job, and you touch and print, touch and print. It's like on-demand type of labeling, right? Otherwise, you have to look at the sheet and see where you're going to stick the labels. There's all the individual parts with their toolpaths on them and the individual programs. So that's for a remake. Let's say if a part moved or fell, you could remake it with the program already there for you. There's a simulation as well that lets you pick and see what the toolpaths look like. I think with this one, I used the tool stay down type of nest. You can set the speed, and you can make this into a video as well. But it's basically showing you the sorted order. And we use what's called a rank number. So I have my drilling, for example, is rank number 1. And then my the dados are rank number 2, and cutouts are rank number 3. And you can make something that's rank 1.5, 1.6, 1.61. So you're never stuck between any 2 numbers. You have an infinite number of other toolpaths that can be ranked. But that's the order at which you cut things in, right? You don't have to pick each one of those pieces in order. When you want to make the program, right, manually, you'd have to touch everything to tell it, I want this, then this, then this. We can sort that order for you, and it does go in a closest point. There's all different sorting methods that we have as well. And there's the stay down nest where the tool is staying down and connecting from one part to the other without lifting up. And that it's great technology for reducing cycle times. We can also do common line and 2-sided nests as well. You get a lot of reporting with RouterSim, and the reports have your cycle times for the whole sheet, how many parts are on each sheet, what kind of scrap area you got. All the reporting is saved as either PDF or Excel files, and you can use either one of those. It saves them both. And you can estimate jobs before you take them. You can run the whole job, find out how much material you're going to need, and how long it's going to take to run on the router. All that data was stored from running that job, and it was really just 2 clicks. One click from inside SolidWorks, it did the feature recognition. Then another click on the cut list, or within automation, pick import from SolidSim and then run it. So it's very few clicks. Now here's a different example from inside of Inventor, and it's almost identical. It's got a different toolbar, right? So they open up an Inventor assembly, And these, when you use an inventor, you give everything a part name and you give everything a material. And by the way, even if you don't use materials, we can do it. We'll just separate everything by thickness then. Okay, so if you leave everything on generic material, if you don't assign any materials at all, then we're going to group them together by thickness and say material 0.75, everything that's 3/4 of an inch thick, right? Material 0.5 would be all your half-inch material. So it's worthwhile to use materials because, of course, if you use the materials, you get photorealistic rendering. That's a big advantage to the materials. Plus, that has um, a density, so you can get the weight of the parts, maybe for shipping, for example. These parts are on a material called maple. This one is on a generic material, so that'll just be called material 0.75. There's some SWPL, solid wood, plywood. Here's the I properties, and they're going to add a label field. So you can just call it label 1, label 2. You put whatever you want in the label fields, customer name, work order number, whatever. And that's during the modeling phase. So during your modeling, you can attach manufacturing info to the parts. And they're going to pick the solid sim button, but I see a little metal bracket here on the part, right? So we should have suppressed that or turned it off, or filtered it out, exclude anything on steel, for example. But there's many places where you could turn that off. So even though they're going to run it with that bracket on there, they'll go and remove it later. So you can open it in the cut list and you see, hey, anything that's made out of glass, remove that. Anything that's made out of steel, remove that. You just delete it out of the cut list, or you could delete it when it lays the parts out flat too. So the next step, here's the automatic feature recognition, and this again will make us the CSV file or cut list. There's the CSV that it makes. Yes, to replace it. You can merge it with another job too, and that's going to give us all those parts. And we'll just import that in the router sim and do another job that's from an AutoCAD 3D model. So you don't have to cut that one right away. They're just going to show you there's the right click cut if you want to, or you can see that there's that label field. You see the names. Even though the material is just called maple, it called it maple. It added 0.5, 0.75, and you can see some different quantities on the parts there. The expand and the lay flat is optional. It is, many of our customers tell us that expand thing is really useful for showing how to assemble the products. And sometimes they just use that and put that into a Word document or the assembly guide. You could put a specific amount that you want to expand, and then you could also reassemble. And then once it's expanded like this, you can further move parts out manually. So you can just use move or copy. Here they're going to remove that bracket, right? So they're picking remove parts and touch on that bracket and get rid of that out of the cut list and then re-export it. So there's many places to do that. It's no big deal. You can see the lay flat, and again, all the parts will be long in X by default. And it picks up all the features, beveled edges, counterbores, countersinks, pocket screws. They're all in there. Horizontal routing. You might have heard a 6-sided feature recognition, where it could recognize features on the top and the bottom and the left and the right and the front and the back. Well, we do a step more than that. We have all-sided feature recognition. So if you had like a stop sign and you had drill holes on any of the odd faces of the stop sign, we would pick up the drill holes on any of those odd faces. A lot of software only gets the 6 sides. We do all sides of a model. So If you had a aggregate head, for example, a 4-axis aggregate, you could model and drill holes on any of those sides. This is going to re-export the list without the bracket. And so now I have a new list, a new date and time on there. Those are the things that were ignored. See, they turned red. And then there's all the good stuff that is going to be cut. Okay. That's an example from Inventor. It works the same way from SolidWorks, Inventor, or Solid Edge. It's just one button click. Now, what about everything else like Creo or CATIA or Rhino? Then we use regular AutoCAD and we can import from all those different sources. You can import step files, SAT files, Creo, Rhino, 3DM files. There's a whole list of AutoCAD import abilities. So you can import solids from any other source and then work with the model from AutoCAD. We had the same button click. And also in AutoCAD, we had the ability to name parts using just the AutoCAD part properties. So here we're importing that desk, and that'll build a job for us. And you can see this job tree it's a SQL Server database is what it is. So you can have multiple databases. You can have a database for each customer, for example. There's the part multiplier again. And then they could run that job. But what he's going to do is going to start up AutoCAD and then just open a 3D drawing in AutoCAD. But that's where I think you can just type in import right inside AutoCAD and import from all those different sources too. So here's an open and grab some drawings from a folder. These are 3D drawings. They're already modeled in 3D. So you can use the not just Inventor, SolidWorks type of parametric models. You can grab any kind of 3D models you draw in AutoCAD too. And there's the same button for Solid Sim. You've got the Select Solid button, and you can do the same thing that we did in the other programs. We can do the work from an AutoCAD drawing. So not everybody's ready for a parametric modeling program, but a lot of people might be drawing in 3D models with AutoCAD. You can work with those as well as parametric models from SolidWorks and Inventor or Solid Edge. Now, once these parts are laid out and nested, you can also mix in your own 2D drawings. So you can add 2D drawings and 3D inside the same assemblies. Here's that cut list is making. And these have part names and materials and quantities. And it can lay them flat. It's very popular for the frame industry or plywood frames. Here's the import on that cut list that it just made. So now he's got 3 different jobs, one from SolidWorks, one from Inventor, and one from AutoCAD. And those 3 jobs are right here in the list, right? We can make a new job and pick add assemblies and say I need 3 of the chair, 2 of the reception desks, and 3 of that other thing, the tower. So you can put in quantities there, right? So this is a job that has other jobs inside of it. That one, we're going to turn off the multiplier because instead of having 10, right? If it's in a new job here, whenever you said one of those, you'd really would get 10. So there's a way the multiplier can multiply even further. But there you can say so many of each of these parts, right? So you have a job that has other jobs inside of it. Very useful because let's face it, you're going to have maybe model a desk and model a cabinet and model a table. And you can say, give me 3 desks, 2 tables, and 1 cabinet. And that's what's going through the process right now. It looks at the layers, makes the tool paths, the layer to knowledge each time. Anything on layer cutout that's an inside, anything on layer outside gets outside. And we could specify different sizes of small parts too. So you have a way to recognize parts that are large, small, and extra small. 3 different sizes. And the smalls, for example, could have a tab, and the extra smalls could have an onion skin, for example. And the largest can go counterclockwise, and the other ones go clockwise. So you can specify, or at least the rank number, right? The extra smalls are rank 1, the smalls are rank 2, and then the larges are rank 3. You want to be able to cut the little guys first so you have the most vacuum. And then here's all the different materials that are being nested upon right now. So you could have maybe 3, 4, 5 different materials, and they'll all get processed for you automatically. And you'll have a different nest. So out of all those different jobs, and there's that multiple stock size again, right, where we got different size materials. And that's a tool stay down nest, even on these odd sizes. We're using stay down version 3, which has a built-in overlap and an arc in and an arc out. That's as good as it's going to get for stay down. Means that your tool paths will connect from one part to the other very smoothly without an abrupt stop and lift up or plunge. There was a piece of scrap left over on one of those jobs. You can cut this, make a scrap cut and save it for next time. So there's automatic scrap cutting and saving in RouterSim. And so you see it had like 5 or 6 different materials on there. There's also a skeleton cut. How many times you have a long piece of a material left over at the top? We can use the router to chop that up into maybe 25 inches long, so you don't have to whack it against the dumpster to break up the long scraps. There's a great automatic scrap management system. It'll roll the scraps into the next job for you. And so that was a good example to show you, hey, look, it took 3 different assemblies and mixed them together with large quantities of each. Some of the stuff we didn't talk about here in this video was things like cart control, where, if you have 10 different customers mixed together or 10 different products mixed together, you wouldn't want all 10 products on one nested sheet, right? Because you probably have a cart to take the parts off the router and put them onto a cart, and then they go to paint or to finish wherever they go next. So you can limit that and say, okay, no more than 3 carts at a time. So it wouldn't have more than 3 different customers at a time on a single sheet. It's great for unloading that way. So there's all the results. We got hundreds of single part drawings, and then we got all the individual NC code files for all those parts. Then we get the nested sheets for all those parts. We got the labels for all those parts, and we got all the reporting for all those parts as well. So you can get a lot of data very quickly in the RouterSim. And like I said, the labeling is all fully customizable. There's even something called multi-post that lets you take and run these jobs for multiple machines. Run it for an Onsrud, then output it for a BSC, and also output it for a HOMAG. All 3 of those machines need very different code, but we've got a multi-post feature that lets you output the program to multiple machines. There's another feature in there too called automatic G-code scanner. And what that does for you, it automatically checks the programs. If there's any Z values that are too deep, it'll check them and put them in a separate folder for you. All right, so in conclusion.
Thanks again, Kenny, for demonstrating Simtek's approach for managing some of the challenges of working with 3D models. As time marches on, we gain more and new tools to help us keep our production levels in a position of growth. such as the advancement of 3D modeling. With these tools come the need to overcome new bottlenecks to maintain our upward momentum, like some of the ones that we've discussed today. We at SimTech constantly strive to widen one of the biggest pain in the bottlenecks. There never seems to be enough time to get all this programming done. We believe our software, like the SolidSim program that we've displayed today, can truly bridge the gap between the benefits and bottlenecks that come with 3D modeling, and most importantly, save you time between 3D to CNC. And now let's get into the Q&A section of the webinar. It does look like some of you did start submitting some of these questions in, and so we do have a couple to work with. First one, Kenny, that we have popped up. Does SolidSim only work with assembly models, or can it handle multi-body part models? What are your thoughts on that?
Either one, right? It works with either one. So it works for multi-body parts, no problem at all. Depending on your modeling program, though, the name might become an issue. So it'll start using the original assembly name and then number the parts 1, 2, 3, 4, etc. Right? If it's a full assembly, then each part needs its own name. But when it's a multi-body, you don't always get the whole name for each part. So it'll use the multi-body name and then start numbering it. But it says full support for multi-body parts. No problem at all.
Great. Thanks for clearing that up. Hopefully that helps solidify some things for people. We did have another one pop in. Can I mix 2D drawings with my 3D models?
You can. And in Router Sim, you can mix in also parametric macros. So you can have 2D drawings, 3D drawings, and parametric macros all in the same nest. Now, any of those nest results that we got, you can edit those, open it up in AutoCAD, and drag and drop something else in there, or draw your own parts in there, and move them around, fit them in the nest, and resequence that sheet. So you can mix and match any kind of data inside the same nest.
Great. Thanks for breaking that one down too. We did have another one come in. Does SolidSim support edge banding? And if so, how does that really work?
It does. There's a whole section on edge banding in the SolidSim, and there's two schools of thought there. One is, hey, I'm going to model the part to the correct size and then add the edge banding as a separate object. And then there's the other one where you could just paint the edge a different color. So you can paint it red or blue or green, whatever you want. You can put a different appearance on the edge of the part, and then we'll see that appearance, and we can offset that edge in for a pre-mill or offset it out, make the part bigger. So we can add pre-mill extensions based on the appearance of the edge, or you can model it to true size, and we'll pick up the true size. So we support edge banding multiple ways.
All right. Thanks, Kenny. And that just about concludes our time in today's webinar. We at SimTech would like to thank everyone attending today. And with that, we'll give it back to Ryan to close us out.
Okay, well, thank you. Maximizing efficiency is always a top priority for all businesses. So thank you to Kenny and Giovanni for educating us on how they can help your facility achieve results. The Woodworking Network would like to thank SimTech for bringing this great information to our viewers. You can learn more at the SimTech website, which is, I believe, on your screen. Big thank you to those viewers who took the time out of their day to learn more about the latest in our industry. Please be on the lookout for additional Woodworking Network webinars throughout the year. Thank you, everybody.